How's it going, everybody? And welcome to another episode of Tech Support Thursday, actually being recorded on a Thursday. So in this video, I'm going to go in reverse instead of doing the older, what do you call it? Older questions that come in. I'm going to do something that's new simply for the fact that it came in just recently. And we're going to talk a little bit about some BGP today and go from there, hopefully to answer some questions and stuff like that. So our friend JK Rowell has definitely been dropping a lot of questions lately, comments. So hopefully that'll answer some questions maybe somebody else has had. So let's go ahead and dive into this. So we'll take them in the reverse order. So we'll say hardest BGP feature and go backwards. So what a hardest BGP feature that you came across in your studies? So let me think here for a second. I think probably one of the more complicated ones that it took me a while to understand was MED, the multi-exit discriminator. Not because it's inherently difficult to understand, but it was the concept of being able to trigger traffic to influence how the other providers are going to send traffic to you. Communities made sense and things like that because I'd used those before and stuff like that, but it was just one of those things where as you're digging into the technology, it was a little bit complicated to deal with. So that was probably when I first got started. Now, I'm a pretty honest person and I like to be transparent. So conditional route advertisement for me has always been I don't know why, but the geometry going on between my ears has always made the exist map and the advertise map and the non-exist map and the advertise map and the table map. Those specific variables have been very difficult for me to wrap my head around. I don't know why, it just is. So that, and then things like add path and BGP pick, the prefix independent convergence, which is one of the reasons why when I was talking about yesterday on the live stream, and I can actually show you the topologies I have it right here. Is it this one? No, it's this one. Let me go ahead and log in just real quick, just so you guys have a visual representation. I had to rebuild my BGP topology so that I could support things like add path and pick. So when I originally, the topology that I was first rolling out was going to cover both IGP, BGP, and multicast. Well, I'm redoing the IGP one. This will be the IGP topology, OSPF, IS to IS. We'll run EIGRP and RIP. We'll do some redistribution. We'll play around with route policies and capabilities and things like that. It'll allow me to take a little bit deeper than what I was originally intending to do. Stuff like that. We'll play around a little bit with first hop redundancy. We'll play around with HSRP, VRRP. Even though they're not explicitly written on the blueprint, there is the possibility that you could run those on the platform. So I'm just going to cover them just to be thorough. So going back to this topology, when you get into things like add path and backup paths and things like that, so the route reflector is going to, and we'll talk a little bit more about this. There's another question here that we're going to dig into a little bit. Let's see if I have hardest PGP feature. I'll have to see if I can't find that. Oh yeah, it was right here. So when we look at how this topology is set up, the add path, it really is going to come down to just having to lab them up. That's really what it boils down to. So this topology is going to be pretty big. It's a deep dive into BGP. So it's going to start off at like the CCNA level, and then as you're going through the workbook for service provider, it'll quickly ramp up to more and more complicated stuff, both IPv4, IPv6, both unicast and multicast. So that's my intention with a lab of this size, so I can play around with different traffic engineering techniques and things like that, because I wanted something that was just going to be like, I would be able to play around with just about any variable with BGP and be able to get the job done. So that was the point with that one. So let me dig into this one here. So I'm assuming this is a comment off of the IBGP full mesh and the requirement and the reason why you would go with route reflection. So very interesting. I was wondering, how do route reflector work in the ISP cores? My instructor said at one point, ISPs that don't connect their customers to the internet don't necessarily have route reflectors in their core, while ISPs that have their customers access the internet through them must have route reflectors in their cores. I don't know where he's getting that from, or whoever this instructor is. I don't know where they're getting that from, because to me, and I don't mean to throw any shade at whoever this person is, but if I was to take this comment back to the team that I work on, I would get a lot of shaking heads, because anybody that knows how BGP works would tell you right out of the gate that that isn't the case. So I think what we need to do is dig into some of the specifics first and some of the facts versus maybe an opinion on how something works or a particular design that they would go with. Out of the gate, I am a proponent for route reflection at any point in time. And the reason why I'm a proponent of that is because it is a configuration scalability mechanism. Same thing with, like, if you're going to use peer groups or session groups or address family groups or anything like that inside of XR, or if you're going to use the templates in iOS, things like that for configuration scalability, so you're not having to associate 4 or 5 different commands on a per neighbor basis. You put it into a peer group or a template for your peer policy or your peer session, or if you're in XR, you're doing your session group or your address family group, where you can try to optimize your configuration a little bit so you're not having to repeat the same configuration for every peering. It makes your scaling a little bit better from a configuration perspective, where route reflection is a way to get around the IBGP full mesh requirement. So now my comment to that was route reflection makes it easier. However, only the best route is advertised. I'm working on digging into that. So then the response is, may you elaborate this point in your next video, the usage of route reflectors in the ISP core, and if the ISPs that connect clients to the internet are more likely to use route reflectors, and why. So here's the thing. It can go either way. And one way isn't necessarily worse or better than another way. So the specifics, let's talk a little bit about that. First of all, do you have to have a route reflector? No, you don't. Does a route reflector make your job easier operationally? It can. And what is the goal of the route reflector? The goal of the route reflector is to take, and I'll bring up topology here, all these routers here, R9, R10, XR27, XR26, they are meant, and so same thing with R17 and XR34, they are meant to be route reflectors for those specific autonomous systems. The first thing you got to remember is route reflection only works with IBGP peerings. It doesn't work with anything outside of the environment. So that's the first thing. It's IBGP scaling. That's the first thing you want to look at. Do you need a route reflector? No. If you don't have a route reflector, how do you scale BGP? Well, then every one of your routers in your autonomous system must peer with everybody else. So that's n times n minus 1 over 2. And then what that equation comes out to be, if I was to, let me pull this up real quick. So the equation is n times n minus 1 divided by 2. Now, what does that equation actually mean? So to put that into layman's terms, it's like this. If I have n meaning the number of devices. So let's say I have 10 devices. I have 10 routers in my core. Well, actually, let's do the one at the bottom here. Let's do AS101. We'll say we have 6 routers in the core. So you need to take 6 times 6, right? So that's going to be 36. But the reality of it is my peering connectivity is going to be minus 1 because you can't form a BGP peering with yourself. So I have 5 other peerings. So it's going to be n times 5. So it's going to be 6 times 5. And what is that going to equal out to? That's going to equal out to 30, right? Now, that's my 6 here is the n. The n minus 1 is going to be 6 minus 1 is 5, which equals 30. Now I'm going to divide that by 2. What does that equal out to be? That means 15. I'm going to have a total of 15 IBGP peers. So that's going to have, you're going to have one here, one here, one here, one here, and one here. And you repeat the process over and over and over again. Now, that's the IBGP full mesh requirement. Will BGP still work the way you expect it to? It will. However, here's another caveat. When I'm looking at route advertisements, and let me go ahead and, I don't have my pen tool pulled out here, so let me go ahead and grab that real quick. I feel like this is one of those things where you just kind of need to draw it out to prove your point. All right, so let me go ahead and make this medium, and we're going to go to, we'll say, orange, so it's easier to see. Okay, let me grab my pen, and we're going to do a little bit of drawing here. Okay, so now assuming that I don't do anything fancy with my routing, move my mic back a little bit so that I'm not shouting in your guys' ears. So if I learn, let's say this guy advertises a prefix out, right? So R15 learns it. R15 then propagates it to every one of his IBGP peers. So every one of these guys gets it. Whoops. Right, they all get it. Now, what do? Let's assume that they're all eBGP peered over here. Oop, I don't know why that did that. They're all eBGP peered, right? Which means that now 20, 21, 13, and 31 all get it. Excuse me. Just had lunch a little while ago. So, and the propagation is going to continue. And let's assume that for the sake of argument, that 34 is working, and then we form route reflection. So he's doing route reflection everywhere in the network. Okay? Now, 43 advertises a route. So 16 is going to get that. Where's 16 going to send it? 16 sends it to the route reflector. The route reflector then sends it to every other route reflector client. 13 gets it. What does 13 do to it? 13 sends it to 28. 28 has 41's route. What does 28 do? He sends it to 13. The question is, do 28 and 13 advertise it outbound? No, they don't. Well, why not? Well, at least the way that I'm going to build my lab, they wouldn't do that. Why not? Well, because I am doing IGP routing plus RFC 1918 address space in my core. Okay? Well, why does that matter? Well, that matters because I don't know the next hop. I don't know how to recurse to it. So when you look at something like this, where this prefix right here, let's say this is going to be a public address space. If 16 doesn't know how to get to this particular prefix, let's say it's 13.28.0.0/24. If I have this address here that is not learned by the core, and that goes both ways, it goes both directions, will the route get learned? The answer to your question is no, because you won't be able to recurse to the next hop. So if you can't recurse to the next hop, it doesn't matter if I'm doing route reflection or IBGP full mesh. So what I need to go do instead is I need to go on anywhere there's going to be an eBGP peering anywhere. I need to go to all of my peerings. If I'm going to be learning eBGP up peer, if I'm going to have form an eBGP peering anywhere, and I need to advertise a route that I'm getting internally, what do I have to do? I have to go through and I have to update my next hop. So with that being said, what I have to do is I have to go for anywhere I have an eBGP peering, so literally on all of my routers, I have to go set on the neighbor statements. I have to either set next hop self, so instead of you getting the next hop of this IP address, I set as my loopback, right? Okay, that's something that's reachable by any of the routers in my autonomous system. They can reach that, and they're good to go. Now it's a different. There's the next hop self option, or you take this prefix, this link right here, or this link right here, and you advertise it into your IGP. So you advertise your directly connected links into your IGP, typically through a passive interface. So you would enable OSPF or ISIS on the individual interface, passive interface, so it doesn't accidentally form an IGP peering outbound, because you never know who you might be forming peering with by accidentally. Now, once you've accomplished that, does that change things? It does. As soon as the next hop is recursable, then the route will get advertised. If you ever look at the BGP best path selection algorithm, the first one that you look for is what? It's weight. Right, that's the first thing that you can modify because it's a Cisco proprietary mechanism. But in reality, it's one in the best path selection algorithm, the BPSA. However, when you look at it from a recursion perspective, it's technically number 2. What is number 2? Or what is the actual number 1? It's going to be a recursable, or I should say, reachable next hop. That is the actual first one. If it says inaccessible, that is not what you want to have. If it says inaccessible when you do a show BGP IPv4 unicast 10.10, whatever the address is, plug that in, and if you see inaccessible, I believe it'll be in parentheses. If you see it says inaccessible, that's a bad thing. So you have to make sure that the next hop is reachable, either by going to next hop self on your edge router or by taking the link that connects the eBGP peering and is advertised into your IGP, so your IGP knows how to do that. And in the workbook, I will be demonstrating how to do both. Next hop self is typically more elegant, I guess you could say, because it's a single command, and then you're not dirtying your routing table by advertising local subnets into your, or directly connected subnets into your IGP. So that's how you would typically go about doing that. So that's essentially where that comes into play. Now, hopefully that's the first thing that I wanted to talk about. So let's go ahead and I'm going to clear the screen off. Let's go back over here. It says that ISPs that don't connect their customers to the internet don't necessarily have to have route reflectors in their core, while ISPs that have their customers access the internet through them must have route reflectors in their core. And that is not true at all. And I just explained why that's not true. The only time you need to have a route reflector, and technically speaking, you don't need to have a route reflector. A route reflector is a configuration scalability option. It has absolutely nothing to do whether or not you connect a customer to you or not. Here's what a route reflector will do that it goes above and beyond what a lot of people realize, and it's more specific to MPLS VPNs than it is anything else, is whenever you're doing a route reflection, the route target value will get ignored because the route reflector's job is to just ingest information. Now, there is an address family called RT filter, or route target filter, that you can leverage, that you can be specific on a per address family basis and neighbors and stuff like that. But in the grand scheme of things, when you're dealing with a provider core like this, as long as you have full mesh reachability, in other words, you have a peering to every other router in your network via iBGP, whether it's loopback to loopback, which is ideal. That is the ideal way of going about doing that. So as long as you have those checkboxes checked and you've met that iBGP full mesh requirement, either by doing a full mesh or by going through and doing route reflection, it doesn't matter which way you go. So whoever this instructor is, said that you must have route reflectors in their cores, that is not the case. Because high-level BGP would tell you that's not the case. And I just explained why that is not the case. Now, are most providers going to go with route reflection? Yes, they are. Because it just makes more sense. Unless there's a specific reason inside their environment where it doesn't make sense. But the reality of it is, if you want to talk about just the operational pieces of how BGP works, the fundamental understanding of how iBGP works, the route reflector is not required. It's a nice to have. It's supposed to help you scale. But that is not the actual case. So the reality of it is, though, that you're probably not going to find a provider that's not doing route reflection. So there's the real world answer, which is route reflectors are going to be used, but the BGP core understanding and competency that I have and I want you to understand is that That is not the case when it comes to how BGP operates. So I don't know why this person said that. I don't agree with them, and if I would have been in the class, I would have argued against him and be like, okay, then show me exact. So what I want you to do is, like, in order to prove your point, to make sure that you're 100% accurate on that, I want you to show me in a lab exactly what you mean. But see, that would be the I know better, and I would have called that person on their BS, because that's to me what it is. It's BS. It's not an actual requirement. They must means required, or you have to do this. There's an underlying reason you have to do that. There is none. It's an optimization, is what a route reflector does. So, I've taken this internally to my team, and I said, okay, I got a weird YouTube question. What do you BGP gurus? And I want to be clear here. I'm not going to mention names of the guys on my team, but 3 of the 6 guys that are on my team came from large internet service providers, and they themselves, the guys that I asked this question to, were the managers or technical leads on building out their own ISPs. And we're not talking these little regional based, southeast. We're talking nationwide, full internet routing BGP cores. So when I asked this question, they're like, no, that's not the case at all. You're going to use route reflection. That's just the bottom line, because it just doesn't make sense to not use route reflection. But core competency, no, you don't need a route reflector to do the job. IBGP will do the job just fine with the full mesh requirement, but it just doesn't make sense to do that from an operational perspective. It's just way too much burden. So if that is where this person was going, I would have said, okay, then you need to clarify yourself that route reflectors are, while ISPs that have their customers access the internet through them must have route reflectors in their cores. That is technically not accurate. It is an optimization and a good to have to try to make sure you're scaling BGP correctly, but it is not a requirement. So that's why that must really bothers me. I'm very quick in my own personality to, whenever somebody says, I guarantee this, unless they can actually do it, I'm like, you can't do that. You can't guarantee me anything. I'm very quick to do that, because the engineering brain that I have is like, okay, guaranteeing means that you can 100% all the time, 100% of the time for every instance that I might bring to you, you should be able to meet that obligation. And depending on the scenario, you can't. So I don't mean to harp on this one, but it bothers me when people say this, and I guess you could say I was triggered by it, which is why I wanted to cover it in the video. But that's essentially where that would come into play. So let me go ahead and see if there is any other questions in here. Why is it hard to apply MPLS for the internet? I mean, from the SP network side, nothing would change due to BGP VPN-v4 label, right? Well, so MPLS is just a transport, right? At the end of the day, it just, instead of you using IP routing, you're using a label to get traffic from one part of the network to the other. Okay, that's the key concept here. So if you want to use MPLS in your core versus IP routing, that's fine. So, and yes, you're correct. It would be VPN-v4 would be it would be the labeling mechanism. So BGP VPN-v4 is the labeling mechanism that associates labels for any customer learned routes. However, if you are trying to do an MPLS core, for example, and you want to go through and offer internet as a service, and you have a dedicated VRF for that, or it's in the global routing table, and you want to provide access to your customers via that service, then you're going to have to do route leaking. You're going to have to leak that default route into those VRFs that customers are paying for access. That is going to be something we're going to talk about when we get into MPLS VPNs and how you can do things like shared services, central services, or extranet, or internet as a service, things like that. those are going to be some things that you can definitely uh, operationalize. And there's actually a way to do an MPLS default route through LDP. You can, it's been a while since I've done it, but there is a way to advertise a default route through MPLS. So if you need to target it to some point, you can do that. And now that I'm thinking about it, I'm gonna write a note down on how to. I'll probably put a couple firewalls in place just because of the fact that it makes sense to do that. So another comment was, is complex VPNs a big part of the SP track? It's pretty much the main concept of the SP track. When you start digging into the details of how complex VPNs work, the whole point of the service provider track, the main thing you're going to have to work on is going to be MPLS and segment routing. They're both labeling mechanisms in order to do label forwarding. One's a little bit different than the other, but for the most part, LDP and segment routing, conceptually from a labeling mechanism and how they associate labels, is predominantly the same. They can there's one label space that they both pull from, but segment routing is specific. You have the sRGB, the sRLB, the global block, and the local block. Each are allocated a little bit differently and have different purposes. So when we get into segment routing, I'll talk more about that. But yes, complex VPNs, you've got layer 2 VPNs, whether it's E-Line, EPL, E-Tree, E-LAN, VPLS, HVPLS, PBB, EVPN, VXLAN, EVPN. I'm going to be digging into all of them as we get further along and how they come into play. But at the end of the day, complex VPNs, then you get into layer 3 VPN and all the complexities with that. Then if you've got layer 3 VPN deployed with BGP as your PE to CE routing protocol, and you're doing like inter-autonomous system VPN, whether it's A, B, C, or D, and then or carrier supporting carrier, and then you have multicast VPNs, where you're going to run multicast on top of your layer 3 VPN with PIM or multi-point LDP, or MLDP as it's short for. So there's a lot of different things that are going to come into play with that. So that's one of those questions where you really have to know what you're walking into when it comes to the SP track. May you please talk about the AS path override feature. AS path override. Well, I've really never dealt with it as a standalone feature. So if I was to look at, that is MPLS, layer 2 VPN, layer 3 VPN, I need BGP unicast. Is that routing configuration guide? So let me go up here to this guy. We're going to go to BGP. So we're under BGP, and we're going to look for AS override. Okay, BGP AS override. So what does BGP AS override do? So let's go find the command here in the output. It's probably down here at the bottom. AS override. Let's go to the bottom here and find our thing to scroll up here. BGP AS path override. Configures AS override on the PE router. This causes the PE router to replace the CE's ASN with its own PE autonomous system. I don't know why I couldn't think of that. I was thinking about AS path relax. That's my mistake. So it is a capability of, I don't know why the override like that threw me through a loop. I was thinking AS path relax is what I was thinking. So AS path override, you've got AS path, sorry about that. So the concept is actually very, very simple. If I have, go back over to this topology. Let's say, for example, the CE41 and CE35 are both peering by, that'll work. CE41 and CE42 are both peering with AS101, but they have both the exact same, the CE41 and 42 are using the exact same autonomous system number. Well, and they're both eBGP peered to AS101, what's going to happen is if 41 advertises a route, 42 is not going to receive it because 41 and 42 are sharing the same autonomous system number. You are going to drop that update because you are in part of that autonomous system, so you should already know about the route through iBGP. So what the other one is going to be what's the command? I'm surprised I'm having a hard time with this one. AS something. One second here. Let's just pull it up. Which one is this? Let's look at 15. Oh, this is the wrong one here. Let me pull this guy up. Okay, so 15, for example. I know this router isn't configured, but let's say this router BGP 101. If I have a neighbor, yes, that's fine. Neighbor 1.1.1.1, and I want to do allow ASN. That's what it was. So allow ASN means that I'm going to accept my AS path, or my AS that's in the AS path list inbound. So 41 and 42 would both have to configure this command on their side. Where AS override is the provider doing it for you. So I've had to use allow ASN once or twice because somebody that was deploying BGP, doing the BGP PE routing, when they went to go deploy, they didn't know ahead of time, or for whatever reason they decided to use the same autonomous system on every location. And the provider had configured their settings on their side, and for whatever reason the customer, this engineer, didn't realize that there was an AS path filter. It's an AS path loop prevention mechanism, right? So you don't accept your own AS in the AS path list inbound. So I had to go, and on all of his BGP peerings, I had to go in and add that command, and then we were able to receive the routes. So that's where allow ASN would come into play, where AS override is done on the provider side. So it's override matching AS number while sending an update. So the provider will replace your autonomous system number. Let's say we're doing 41 to 42, or I'm sorry, 41 to 41. Well, what will end up happening is 15 will replace 41 with 15 or 101, right? So it'll say you'll see AS 101 twice in the AS path versus seeing the other autonomous system number instead. That's what AS override is. Because for some reason I was thinking AS path relax. I'm like, well, I have to go look it up. I don't think I've ever demoed that one. So there's that particular feature. So I'll get to one more real quick here. I had an interview for a technical expert position and came across one interview question that the interview stressed on. Apparently, the answer was BGP AS path list override feature. Okay, equals, is the AS path override feature in the RS EI track, or is it in the SP track? Because to the best of my memory, I don't recall it being in the EI track. It's in both. So if you are a route switch engineer and you are standing up the BGP peering to an internet provider or to an MPLS provider or any other combination, and regardless if you're using a public AS or not, the command is there in the event that somebody doesn't do their due diligence in trying to figure out, if I do my peerings incorrectly, then I won't be learning any routes if I have the same autonomous system at all of my customer sites. So if you're going to be doing BGP, one of the key things you're going to want to do is, even if you're doing peering with the provider with private autonomous system numbers, 64512 through 65535, when you do that, you're going to want to make sure that each site has a different autonomous system number, or else you're going to drop the prefixes, and you're going to be like, well, why aren't the provider will see them, but none of your remote sites will. And if you do a debug to debug BGP updates, and you clear, you're going to see them come in, and your own AS path will be in the AS path list, and you're going to drop them. And I'll demo that. I've done that multiple times. If you go back to, let's see here. Let me pull this over here real quick. Let me go, where did I, see if I can't find it real quick. Maybe just pull up so if we look at the enterprise workbook, real quick here. We're real quick like. So if we look at, where did I put it? I'm pretty sure I put it in here. Maybe it's down here. MPLS, or it should be right here. So that's layer 2 VPN. I meant to go layer 3 VPN. So if we do, did I not go far enough? Let's see here. MPLS. Oh, that's because I did configure, is it? I'll configure and verify. Here we go. Okay, so let's see if I can't find the update. I'm pretty sure I did a we don't see any as okay since it's attached. So it's one of these here that I did the okay, right here. Right here. It said since I had the same autonomous system number, it says we received 10.0008 denied due to AS path contains our own AS. So the route was denied. So if you see this, you have to go on R1 towards router 2. I had to do allow AS in, and as soon as I did that and I cleared BGP, it almost does it almost instantaneously. Then you can see that the route was learned, and you can see that 10.1 it's now learned, and it gets the job done. So now the AS override, I covered this one too, where we do the exact same thing, but on the provider side, you do AS override. And so when you come through, you notice how here we've got an AS path of 101, right? There's the 1. But if you come down here and we do the AS override command, it goes ahead, it's learned. The origin is this guy. So we see 10.0001/32 is now on the routing table, but we see this, and then we see an AS path of 100 because what's happening is you're replacing the AS path, the source AS of 1 with 100. So that's where that comes into play. So that is why it's both. You should know it for service provider and for enterprise or route switch. So that's it for today. I'm at 40 minutes already. I went a little further than I planned on going, but that's okay. So with that being said, if you guys have any questions, comments, concerns, feedback, please drop that in the comment section below. If you haven't already done so, please like, share, and subscribe. And the workbook links will be in the video in the description below. And don't forget that on Wednesday, I am doing Whiteboard Wednesdays, where I will get on the live stream with you guys every Wednesday at 7 o'clock Central for an hour or so to talk about whatever you guys want to talk about. This past Wednesday, we talked about my lab. I'm going to talk a little bit about some service provider stuff since I'm knee deep in it right now. And then on Friday at 7 o'clock Central, I'm doing a members only live stream where I'm not sure if the live stream is the best way to do that, but I'll figure it out tomorrow whether I'm going to go to like more of a more of an intimate way of doing it, like a Microsoft Teams type of scenario where you guys will just join the team session. And we'll go from there. But one way or the other, we're going to figure that out and go through the details of what you guys need to do in order for that to happen. So it'll be a members only, so you have to be a member of the channel in order for you to access that. And then we're going to do, I'm expecting a very, very small amount of people. Probably under 10 if I had to guess, because I think I had 10 on the global public live stream. But that's okay. It was First time out, some people might not have seen the message, but every week we're going to be doing this on a regular basis. So if you guys have any questions, drop a comment in the comment section below. And until next time, guys, take it easy.